Alright, so today let's look at the test 4 review. Your test 4 will be given this Wednesday and Thursday on Math Connect like the last one was. So you're going to need not only your review, but you're going to need the solutions just to kind of check yourself. You're going to want your formula sheet, and then you're going to want, of course, both of your tables. Okay, so those are all things that you're going to want to have out as you do the review. When you do your test, you're going to want to have these formulas and these two tables pretty handy. Okay, so the first thing I want to do before I actually jump into the review, I've had a lot of email questions just in general asking just what's a quick way to know when you can reject H sub 0 or not. This is for chapter 9. So I want you to kind of write this down and maybe think about this for a little while. I think most of you are having confusion because you're trying to mix the two ways. Okay, so option number 1 is you compare the z/t values. Okay, and the issue here is when I give a regular test that's like handwritten, you can kind of choose which method to use and kind of stick with that. You're not really going to be able to do that on an online test because some of the problems are set up to use this method and some of them are set up to use option 2. Okay, so I want to make sure you understand both methods. So here's the gist of this method, and I think maybe a picture might help. If we have a normal curve or even a student distribution, you know, that's a little taller or whatever, okay, then we have a curve that looks like this. In the middle is t equals 0, right? And then what you're going to have is you're going to have some critical values here and here, positive and negative, okay? So this would be your negative z/t, and this will be your positive z/t. So it's z if it's a normal distribution, it's t if it's a student t distribution, okay? So what you have is the normal curve split up into kind of two sections. These values are expected or are okay, and these values are rejected, the ones in the tails, okay? So basically what happens here, sorry, I had to shut my door there. What happens here is here are your critical values. Critical means these are the values we deem important. These are the values that we deem that anything outside of these are going to be not okay. Okay, so what that means is that anything here, okay, anything that is to the right of the z/t value is rejected. Okay, and the same goes for this. Anything here is rejected, but everything in between is okay or not rejected. Okay, so I'm hoping that picture kind of helps, but here's the process. You're going to find your z/t value using the formula. And if you look at your formula charts, the formulas look really, really close. It's just that for the t value, you're going to be using the sample amounts, not the population amounts. So using the formula, and if the absolute value of your z/t is further out or larger than the critical value at whatever level of significance you're at, then you reject it. Because when you're taking the test, you're not going to have time to go back and try to teach yourself these things. So you really need to kind of firm up when it is that you reject H sub 0 before you try really to even do the review or the test. Okay. So option 1 is you compare the z/t values. Option 2 And again, you're going to need to know how to do both for the computerized test. You compare the p-values or the area in the tail. Okay, that's what the p-values are representing. Okay. So let me show you a picture of that. So again, you have a bell curve. Okay, you still have critical values here. This would be your negative z/t. This would be your z/t. These are your critical values, or the values that are of importance. Okay, and we're still kind of sectioning it off. All of this is okay. Okay, and then anything, notice I'm not going to point to the number line this time. I'm going to point to the actual area here. So you're going to reject any area that is smaller than this tail from the critical value. So if you're having trouble, like when do I know whether it's smaller or bigger, I think your problem is you're trying to morph these two methods in one, and you can't do that. So if you're looking for z values, you're looking to see if your z-score/t score is bigger than your critical value. But if you're looking at areas, you're looking to see if your area is smaller than the given area. So let's kind of run through the steps here. You're still going to find your z/t value using your formula. But here's where it's different. Then you're going to use your table to find the area that's associated with that. So then use your table to find the area in the tail/tails. Remember, if it's two-tailed, you'll have 2 there. And if your area is smaller, then you reject it. So let's just finish writing this out all the way. If your area is smaller than the area you were given with a certain level of significance, again, then reject. Okay, so think of it this way. Small areas here represent areas that are unexpected. Okay, the smaller the area, the more unexpected it is. Okay, and just the same way, large in the absolute value way, large z and t values are unexpected because it indicates that we're further out from the middle than we thought we were. Okay, so really, I hope you'll pause this video and kind of maybe go back and look at some of the older questions that you have, and I hope this will kind of clear up any confusion that you have. All right, so now let's go ahead and get looking at the test for review. All right, so the first question is, if I can find my review. The first question says, we have a situation, right? The first thing you might want to do as you read a question is figure out whether you think sigma is unknown or not. And notice if you look in part B, it looks like sigma is known. So when you have sigma mentioned, you're going to use z values. You're going to use a normal distribution. Sorry about that. Move that down. Okay, so if you read through the problem, you do need to know how to set up a hypothesis test. Hypothesis tests always have 2 parts, the null and the alternate hypothesis. Okay, so the null is always that the mean is what it's stated to be. Your null hypothesis should always be mu equals something. okay? But then the alternate hypothesis, you have to read the problem. So it said that we want to know if the mean height for older men is less than the mean height for regular men, basically. Okay, so notice this is a left-tailed test since we're less than. Okay, so a couple of things we need to remember. That means we're going to expect negative z-scores. Okay, we're going to be comparing things that are smaller than what we expected. Okay, so let's look at part B. Notice you were given a few things that we're going to need to find the test statistic. So we have mu is equal to 69.4, n is equal to 300, x bar is equal to 69.0. Okay. So we also were given that sigma is, can't find my review, 2.84. Okay, so we do have a z-score. So it's going to be x bar minus mu, and then over the standard deviation divided by the square root of n. Okay, make sure you use parentheses around the top and the bottom when you figure this out. But you should get a z-score of negative 2.44. Okay, so let's go ahead and use the p method for that just to make sure we know how to do both. I'm going to kind of mix them up basically. Okay, so this corresponds to an area of, and let's look at our chart, right? So you find negative 2.4, and then you go over to 2.44, so it's 0.0073. Okay. All right, so I asked you to find the test statistics, so that would be the test statistic. And then in part C, it says state a conclusion, so we're using the area model. So notice, and it asks us to test it at the 0.01 level of significance. Notice that our area is less than the test area or the critical area, so that means we reject H sub 0. Okay, and so the conclusion then, your conclusion is always, do you have enough information to make a conclusion or not, basically. We do, right? Since we rejected H sub 0, we can say that the mean height for older men is less than the mean height for all men. Okay, remember there's really only two conclusions. Either yes, you can say whatever you were trying to prove is true, or it is inconclusive. That's your only two options. Okay, okay, so let's look at number 2. So number 2 is kind of similar. Okay, notice in number 2 it also mentions sigma. So since sigma is known, then we're going to use the z values. So same kind of process. First, we're going to set up the hypothesis test. Okay, so the null hypothesis is that mu is what it's stated to be, which is 1,000. But the alternate is that it's something different, which means mu is not 1,000. Okay, so this is going to be a two-tailed test. All right, so let's write down our information. We know that mu is 1,000. We know that n in this problem is 50. X bar is 1,000.6, and sigma is 2. Okay, by the way, we're trying to determine, is it weird that the overall population mean is 1,000, but the 50 we sampled have a mean of 1,000.6? Okay, in other words, is that too different from this in that it's unexpected or something? So let's see. So we're going to find the z-score. So it's sample mean minus population mean over standard deviation times the square root of n, or sorry, divided by the square root of n. Okay, so notice we get z equals 2.12. Okay, so that is the test statistic, but again, I'm going to do this the area way, just because I feel like this is the most unused way, so I'll switch to the other way in a little bit. But this corresponds to an area. If you look on your table, the area is only for one side. So since we have two different tails, we are going to have to double whatever we read on the chart. Okay, and by the way, you have to look at the negative version. In other words, if you look here, you don't want to read 2.12, okay, because 2.12 is everything from here back, and we're trying to get the tail. So what you actually have to think about is that there's actually two z-scores. There's actually plus or minus 2.12 because it's a two-tailed test, okay? So we actually need to look at 2.12 here. It's actually 0.0170. So here you actually always have to look at the negative z-score. Okay, so this works out to be 0.034, okay? So now when we get to making our conclusion, notice that 0.034 is not less than 0.01. So that means we do not reject H sub 0. Okay, so then our conclusion, remember I said there's only two forms of the conclusion, and so this is the second one. So basically, we cannot conclude if the scale is out of calibration. So it doesn't mean it is, it doesn't mean it isn't, it means we can't make a conclusion. Okay. All right, so let's go on to number 3. Number 3 is kind of a overview on the different types of errors that you might have, or maybe it's the correct decision. Okay, so let's read A. I went through kind of a lot of them here. On the test, you might only have one of these, but you need to know all of them so that you know how to, so that when you randomly get assigned one, you know how to do them all. So let's look at part A. So a test is made, so we think mu is 30. The alternate is that mu is not 30. Okay, so it's a two-tailed test. The true value of mu is 25. So think about that for a minute. It means they were wrong about what mu was. And so H sub 0 is rejected. That's the correct decision, right? It is not what we thought it was. And so it should have been rejected, and it was. So it's the correct decision. Okay. All right, let's look at B. So in B, we think mu is 5 versus maybe mu is greater than 5. Okay, the true value of mu is 5. So let's stop right there. That means we were correct originally, and that means H sub 0 should not be rejected. Okay, but then it turns out that it was, and remember, that's a type 1 error. So type 1 errors is when we wrongly reject H sub 0. Okay, when you reject something that you shouldn't reject, that's a type 1 error. All right, C. We think mu is 30 versus mu is less than 30. The true value of mu is 25. In other words, the original hypothesis was not correct, but we did not reject H sub 0, so that is a type 2 error. We should have rejected it because it was wrong, but we didn't. So we didn't reject H sub 0, but we should have. Okay. And then lastly, we think mu is 45 versus mu is less than 45. The true value of mu is 40, so stop there. We are wrong, right? We should be rejecting H sub 0, and we do, which means this was the correct decision. Okay, so just make sure you really shouldn't need to look in your notes on the test. You really don't have time to, be cycling through your notes all the time. So you really need to know those errors pretty quickly so that you can spend more time on the, problems that are going to be worth more points, frankly. Okay, so let's look at number 4. All right, so notice number 4, we are not given, if you have to read really carefully, so notice we have a sample of 14, and we are not given sigma. We are given S instead. So if sigma is unknown, it means we need to use t values. Okay, it also means we're going to have 13 degrees of freedom here. Since n is 14. Remember, the degrees of freedom is always n minus 1. Okay, so that is going to change things. It means we're going to be looking at the other table. Okay, but let's state our null and alternate hypothesis. So the null hypothesis is that we think the mean's 35,000. Alternately, the mean may not be 35,000. Okay, so this is two-tailed. Okay, so we are going to find our test statistic, right? The t value formula is just the same. It's just that we use S instead of sigma. So x bar minus the mean over the standard deviation here, right, divided by square root of n. Okay, so this works out to be about 1.507. Okay, so let's use our other method this time. Okay, so this is our test statistic. Okay, so let's find the critical value at 13 degrees of freedom. Okay, so the critical value at 13 degrees of freedom, so let's take out our second table. 13 degrees of freedom, if you read the problem, we are trying to do a 0.01 level of significance, so you need to kind of look up here, but you have to think about it because we have to think about that we actually have a two-tailed test here, okay? So if 0.01 is the level of significance, then that means not all the areas in one tail, it's actually in two different tails. So you actually need to divide by 2. So you're actually at 0.005. Okay. So let's write that down. Find the critical value at 13 degrees of freedom for a tail of 0.005, since 0.01 needs to divide by 2 because it's a two-tailed test. In other words, that 0.01 is the unacceptable area, and you have to split that up into 2 pieces. Okay, so if you look for that value on your chart, I'm not going to show it again because it gets a little tedious, is 3.012. Okay, and then note that 1.507 is not greater than 3.012. Okay, we're comparing, we're not doing areas this time, we're looking at t/z values. This it happens to be a t value. So we do not reject h sub 0. And that means our conclusion is basically inconclusive. So our conclusion is there is not enough info to conclude if the mean tuition and fees for private institutions in California. The nice thing about doing this on Math Connect is all it's going to do is open up a window for you to say is not. You don't have to write down all of this detail we're having to write here. So we were trying to say, does California's private school tuition differ from 35,000, and we can't make a conclusion yes or no. Okay, so we say it's not conclusive. Okay, so last one from chapter 9. Notice in this one, you don't get much information given to you, okay? You do not know sigma. And if sigma is unknown, you have to use t-values. Okay, so this time we have 1, 2, 3, 4, 5, 6, 7, 8 values. So we're going to use 7 degrees of freedom. Okay, so 7 degrees of freedom is what we'll be using. Okay, so part A says, is it reasonable to assume that the conditions for performing a hypothesis test are satisfied? The answer is yes. There's no outliers. Some other things that you want to kind of remember on the test: there's no outliers, no strong skewness, and it's assumed to be a normal population. So all of those things aren't really on your key, but those are all kind of key factors on whether or not you can use these formulas or not. Just kind of assume that they're not going to give you a big long problem that you're just going to be able to answer, no, I can't use that method, and then you're on your way. You're probably not that lucky. So on the test, it's probably going to be, yes, you can use this formula, and now go ahead and do it. All right, so B says if appropriate, but I already told you it's going to be appropriate. So now let's state the null and alternate hypothesis. So the null is that there's 12 ounces in a soda can. That's what it's stated to be. But the alternate hypothesis is that there's some sort of error in filling and it's not 12. Okay, machines fill things like cans and bottles, but they don't always fill it completely perfectly. Okay, so here you're going to have to do some legwork here. You're going to have to find some of the things that you were given before. Okay, so you don't know x bar, you're going to have to figure it out. So you find x bar by doing sum over 8. So I'm going to kind of fast track these. You can pause these and make sure you're getting this. But this is what I get for x bar. Okay. Remember the formula for S is first value minus mean squared plus second value minus mean squared all the way through the list. And then you'll divide by n minus 1, and then you'll take the square root. If you're having calculator issues on this and you kind of consistently on the homework aren't quite getting this, my suggestion would be to do the full top and press enter, then divide it by 7 and press enter, and then finally do the square root. Okay, you can do it all in one swoop, but if you're finding that you're having issues with that, then I'm trying to give you a way that you can maybe do it in baby steps. Okay, so the difference with this question, between this question and the last, is that we had to work for it a little bit, right? We had to find the x bar and the s before we could begin. Okay, so now we can go ahead and find our test value. So it's sample mean minus population mean over standard deviation divided by square root of n. So we get a t-value of 0.973. Okay. So again, I think I'm going to use the same method that I did before. So here's my t-value. Okay. And so I need to find the critical value at 7. I'm going to abbreviate degrees of freedom that way. Degrees of freedom for a tail of half of this 0.05, which would be 0.025, okay, or 2.5%. think of it this way, 2.5% on the left and 2.5% on the right for a total of 5% out of bounds of what we expected, right? Okay, so if you look at that on your chart, on your second chart, okay, so here is 0.025. You go down to 7 degrees of freedom, notice it's 2.365. 2.365. Okay. Note 0.973 again is not greater than 2.365 because we're using the critical value method, not the area method. So that means we do not reject. H sub 0, and the conclusion is we don't have a conclusion, essentially. So the conclusion is there's not enough info to conclude that the volume differs from what they say on the can. By the way, if there was enough information to prove that, then Coca-Cola or whoever made that can would have to actually change what they said on their label. Okay, so there actually is, you know, mathematicians and government kind of making sure that businesses do the right thing. And that's one of the ways, only one. All right, so let's look at number 6. What two qualities does a scatter plot have to have for correlation coefficient to be appropriate? The answer is linear and no outliers. Okay, so that's a quick one. Probably the quickest one we've had so far, right? By the way, chapter 6 starts with the number 6 starts with the chapter 4 stuff. All right, so let's look at number 7. So to save kind of paper space, I kind of wrote it horizontally, but I'm going to rewrite it this way, and I'll do my work off to the side. Okay, so notice we're supposed to find the correlation coefficient. So this is that big table thing. Okay, before you can find the correlation coefficient, you have to have 4 values. You need to find x bar, you need to find y bar, you need to find the standard deviation of the x's and the standard deviation of the y's. Okay, you can't proceed without those. So some of you are getting kind of hung up on those pieces, so you need to make sure you know how to do that. You can, if you will learn how to do it, you can export your numbers when you're taking a computer test to Excel, and it'll figure things like mean and standard deviation for you to kind of get you on the right track, especially if you find you're always making mistakes. So here I get 32.857143. And here you get 207 over 7, which works out to be 29.571429. Okay. By the way, the reason I'm using 6 decimal places is because the final answer needs to be in 3. So you need to kind of use double the amount of decimal places that you expect to need in your answer. So I'm going to set this up just to start. So it's value minus average squared plus the next value minus the average squared plus dot dot dot. All of that over n minus 1. Okay, so this one works out to be, I'm going to kind of, I'll just move this one down. So this comes out to be, again, I'm going to use 6 decimal places, 29.162925. So all of these values are going to get used here in a minute. And then my caution for the standard deviations is just make sure that when you get to the y, you switch over to all the y values. I've done that before where like I forget to go here and I'm still looking at these or something, but it's the first y value minus, now you need to switch to the 29 29.571429 number, plus the next one, which is 52 minus 29.571429 squared, and then dot, dot, dot. All of that over n minus 1, take the square root. So you end up getting 21.747468. Okay, so here's where you're going to set up a table. I'm going to kind of be lazy again and just show you what my table looks like. And you can kind of fill it in. You can pause the video and fill it in. Or hopefully you've already done this yourself. Okay, so let me see if I can get rid of it. It's in pencil, so it's a little bit lighter. But I think if you kind of zoom in, you can probably see it. Let me see if I can zoom in and do an extreme close-up. And then maybe you can pause that and fill it out. Okay, so I think that's pretty visible. So pause it and fill all that out. All right, so I'm going to zoom back out. Hopefully you paused the video already. Okay, so if you worked all that out, the sum from the last column of the table ends up being a negative 3.882611. You can have a negative value on the table. It just means that more of your values were negative than they were positive. That's what that means. Or not, sorry, were less than what you expected and more. So here's your formula. It's 1 over n minus 1 times the sum of all the x minus x bars over s sub x's times y minus y bars over s sub y's. But you already did all of this, okay? All of this is from the table. So what you end up getting is 1 over 6, since it's n minus 1, and then times that negative 3.882611. So r is equal to negative 0.647. Okay, remember, a negative correlation means that as one value goes up, the other one goes down. Okay, positive correlation means they both go up or down together. Okay. Remember also that you should never get an r that is more than the absolute value of 1. It's something between negative 1 and 1. The closer you get to 1 and negative 1, the stronger the correlation is. The stronger they have something to do with each other. Okay, so let's look at the relationship between corn prices and ribeye prices. Okay. If you think about it, those very well could have something to do with each other, right? All right, so the first thing you need to do is probably list all of these values. So again, I'm going to kind of fast track this. The good news is the ones on your test, which I've already seen, I've actually already talked to the person at Grayson. They were going to have really long problems on the test. And so I talked them into problems that only have like 5 choices. So that's going to be a lot quicker. I know a lot of you that are having problems are actually doing the ones with smaller data sets pretty easily. It's when you get like 9 and 10 that you're messing up somewhere. So the problems like this, and actually from 4.2 on the test, are going to be about 5 values or less, which is a lot simpler to do than something like this, right? 10 values is kind of tedious here. All right, so first you do the sum over 10. Okay, Okay, notice that's not even being rounded because when you divide by 10, you just move the decimal place. Okay, you can still get Excel to kind of help you on these. It's not quite as easy because, you know, this review is already typed up for you. You would just have to type the numbers into Excel rather than having it send it for you, but you can still do it. All right, so again, standard deviation, value minus average squared plus next value minus average squared, whole list, divided by n minus 1, and then take the square root. So when I did that, I got this. For the Y version, the first ribeye price is $13.20 minus $13.17 squared plus $13.21 minus $13.17 squared plus so on and so forth, all over n minus 1, square root it. So you're going to get 0.339346. Okay, so here is the table that I did. I'm going to zoom in on it again. You can pause it, write it down, or just hopefully you're comparing it with your own table. And maybe this will help you kind of see like where you're going wrong. Like if you're not getting the right answer and you're working it out and you feel like you know what you're doing, then this should help you see like where is it on my table that I'm tending to make a mistake. Okay. Unfortunately, one wrong error anywhere on this table can mean that you have the wrong final answer. So that's unfortunate, but it's just the way it is. All right, so let me zoom back out. But that's what your table should look like. So then your sum from the last column of the table works out to be 7.333789. And so R is going to be 1 over n minus 1, so that'd be 1 over 9 times that number. And so R works out to be 0.815. So if you compare the last two R values, not only is one positive and one negative, but this is a stronger correlation. It means they have more in common or more that link them together than the example in number 7. It also means with a positive correlation, remember that as one goes up, the other goes up, and conversely, as one goes down, the other goes down. All right, so the last two questions are from 4.2. Okay. Again, I did talk to them at Grayson, and what they're going to do, if you're curious about how 4.2 is going to work, there's going to be one question where you're given all the summaries, like you're given x bar, y bar, s sub x, and y sub x, and you have to write the linear squares regression line and then maybe answer some questions. And then there'll be another one where you have to actually do it all yourself. Okay. But there is the ability to send it to Excel, so I just really feel like with a little bit of practice, you should be able to figure that out. But test time is not the time to practice, so you want to do that early this week if you're wanting to kind of use Excel as your BFF. Okay, so for this one, you're just trying to figure out what the linear regression line is, but you have to know R in order to do that. So the hard part is finding R, is going back to 4.1 and doing that. So you would either send it to Excel or find the sum this way, or sorry, the summaries. Note the bar over the 3 there. S sub x is going to be first value minus average squared plus second value minus average squared, so on and so forth, over 6 minus 1, or 5, and then square root it. So it's 1.87082869. Notice I'm taking it out to 8 decimal places because the final answer is requested in 4 decimal places. Okay, so because these have so many stages, you're going to want double the amount of decimal places until the very end. So S sub x looks like the first, sorry, S sub y, I mean, the first y minus, so I am going to take this out to 8 decimal places, even though it's a little tedious. And so that works out to be 4.36138357. All right, so I'm going to show you the table again. You can cross-check it with yours. So there's the table you should get. Okay, so pause it, check it, zoom back out. So the sum from the table was 4.92070404, which means your R is going to be 1 over 6 minus 1 times that. Which is approximately this decimal. So notice that's all just stuff from 4.1, and then here's where we start doing the new stuff from 4.2. So in these formulas, you find b sub 1 first. So b sub 1 is equal to r times the standard deviations of the y's over the x's. So it's going to be approximately the r times this fraction. And what I get for b sub 1 is about 2.29428573. Okay. We do want to use this eventually, but we don't want to round it to less than 8 just yet because we're going to use that to find b sub 0. B sub 0, you will get this on your formula chart if you glance at it. Okay, so you're going to use the previous values you have. So it's going to be 22.68 and then a bunch of 3's minus that b sub 1 you just got, and then times 4.5, which is the x bar. And so we end up getting that b sub 0 is 12.35904,755. Okay. If you don't know this already, this b sub 1 is the slope, and this is the y-intercept, because it's kind of like y equals mx plus b, just in a different order. So y hat is going to be the 12.3590, if we're doing 4 decimal places, plus 2.2943x. Okay, so that's why I say this is the slope, because it's got the x, right? Usually we see it flipped around where we list the x term first, but it's still mx plus b. Okay. So very lastly, number 10, actually don't know where my number 10 is. Oh, here it is. Okay. So this is more than you ever wanted to know about crickets. Okay, but crickets do chirp differently based on what temperature it is. Never really knew that. I just thought they were annoying. So we have chirp rate versus temp. And so here we have it. Okay. Notice that you can kind of already predict that it's going to be a positive R because it looks like the higher the chirp rate, the higher the temperature, right? The lower the chirp rate, the lower the temperature. So we're not sure how closely they're going to correlate, but they are going the same direction. Okay. So again, let's get all our summary statistics. So if you do sum divided by 6, you should get 2.216. Lots of sixes. And the last one bumps to a 7 because the one after it is a 6. For the Y's, you get 55.2 and then a bunch of 3's. Try to squeeze this in here. Really squeeze it in. So there's a dot, dot, dot there. So I'm just going to do that. And then it's all over 6 minus 1. Okay, so that's that one. I'm going to scoot this one over a little bit since I ran out of room. So the temperatures is going to be first temp minus average temp parentheses squared plus the next temp minus that average temp so it's 14.33885.165. And again, what I hope you'll do is, like, if you're not getting the right final answer, you need to backtrack it and figure out, okay, where am I going wrong? Am I getting the standard deviations wrong? Am I somehow messing up on my table? Like, what is it? You need to figure that out. Okay, you don't just need to wing it and go to the test time and, like, pray for a miracle. Like, you need to actually do the work, too. I mean, pray all you want, but do the work. Do the work and pray is what I'm trying to say. Okay, so there is the table. Pause it, check it, make sure yours matches. So the sum from the table looks like I got 4.6165120. So R is going to be 1 over 6 minus 1 times that. So R is quite strong. Closer it is to 1, the stronger it is. So this is R. I'm going to go ahead and circle that even though it's not quite the final answer, just because we're going to use that so much to get the linear regression line. So first we start with B sub 1, which looks like this. So So it's going to be that times the 14.33885.165 over this. So we end up getting an R of about, sorry, not an R, but a B sub 1 of about 13.94239291. Slide that over. Zoom far enough, zoom too far in before. All right, so B sub 0, remember, is y bar minus B sub 1 times x bar. So it's going to be 55.23 bunch of 3's minus that B sub 1 we just got. Times the x bar. Unfortunately for us, none of these are nice, right? And so this works out to be 24.32783711. So here's our final answer. Y is going to be the 24.3278 plus the slope of 13.9423 times x. Okay, again, this is the slope, this is the y-intercept. Okay, so it might ask you if the slope or the y-intercept is appropriate to talk about. So you need to make sure that the values make sense to you. In other words, like, would it make sense to talk about x being 0 or even negative in order to have a y-intercept? In this case, it wouldn't, right? We wouldn't have a negative chirp rate. So we probably wouldn't talk about the y-intercept. I know that's not on the review, but it very well could be on the test. Strong hint there. All right, so part B, make sure you know how to do these. We did these in class. These were on your quiz. But if it asks you for a change, so if it tells you that there's a change in temp, so I think actually, yeah, so it tells you that there's a change or a change in chirp rates of 1.5. So that means the change in temp based on that is, whenever it says change, you're just using the slope portion. So it's going to be 13.9423 times the 1.5. So it's right around 21 degrees Fahrenheit. Okay. What that doesn't, by the way, mean is it doesn't mean that the crickets cause the temperature to decrease or increase, right? What it means is that these tend to go together, okay? It means that if you tend to have an increase in chirps per second of 1.5, there will tend to be an increase of temperature of 21, okay? One thing that I didn't ask on the review for this question that might be asked on the test is it might say something like, what would you expect the temperature to be if the chirp rate was 2.5 or something, okay? And then for that, you would plug in 2.5 here and figure out what y is. Okay, so it's easy. I think this one is actually the more difficult of the two, but I think you can do either one. Okay, so just make sure you're really kind of well practiced. You know, just because you have the capability to flip through your notes doesn't mean you're going to have time to do that. Okay, so I was able, like I said, to reduce the size of some of these questions, but I'll be honest with you, these questions are still really time consuming. I think you can see, especially the ones from chapter 4, are like time killers, right? So you really need to make sure that you have a pretty firm understanding of all of these things.